Ashley with a video about First LEGO League Challenge, where I will be talking about how to program a robot. Because I have the most experience with and access to the Mindstorms EV3, that is the system that I will be teaching with today. But the same principles and ideas should still apply to any brain that you choose to use with just a little bit of adjusting. Before we begin, there are a few things that students who have never programmed before should know. All programming languages, even this version, are strictly analytical and only understands exactly what you tell it, nothing more. Because of this, it's important to take each step one at a time and grow in your confidence inputting everything that you want the robot to do. Sometimes it can be very difficult and frustrating trying to find out exactly where the issue is or what's happening, but this can all be fixed. Finally, when you begin working with large chunks of robot code or even simple processes that you need the robot to do, it's easy to get lost and other people trying to help you can have a really difficult time. To help with this, there is the ability to add comments to the robot code for it to be easier to follow, and remember to always properly name the programs. These are problems that even professional programmers face in the real world. So starting this habit early can save you a lot of time in the long run. Here we see the programming launcher for the Mindstorms EV3, and from here you'll want to start a new project. You can see up here that the tabs with the project names, so it's possible to have multiple projects at the same time. Within each tab there are also sub-tabs so you can work on different programs individually. This is what the robot will run. The first thing we'll see when you open the project is a block right here. This is what tells the robot to run the code after the program is started, and it's the first block in any code you run. To close out of this box here, you'll want to press the button in the top right. It's generally used to keep information, but I've never personally had a reason to use it as I keep my own logs and notes separately. Now we're going to go over some of the very basics of this programming system. The tabs down here contain different blocks and have different commands. The green tab is for motion. It's where you can move the motors and drive the robot. You can also change the screen display and sound from here as well. Under the orange tab, you can find what's called flow control. These are things such as loops, delays, and different possible outcomes from the code. The yellow tab is all about sensors. You can't use all of these for FLL, but it can be interesting to experiment with if you have access to them. Next is red, all about logic and math. These are generally used for more advanced programs, but they are interesting to play around with and look into if you have the ability. Finally, the blue tab is for advanced programs that I will not be covering in this series. The cyan tab is reserved for my blocks, but I will also not be discussing them in this series either. Now that we've gone through each of the tabs, I will be going over how to make your robot move. The first thing that you're going to want to do is take either of these two blocks and drag them until they connect to the starting block. If it does not connect, it will not run in the program and will be grayed out, so make sure it's connected if you want it to run. In the top right corner of the block, you can see the ports that you are controlling. Typically, the drive motors are B for left and C for right, with the attachment motors using A and D. These gauges here control what % power the motor is running at, with positive values going forward and negative going backwards. This input controls how many rotations of the motor it will go. The distance will depend on what wheels your team decides to use. If you want to change the units from rotations to degrees or seconds, you can do so right here as well. And there's also an option to turn them on forever or make them stop. The last button over here controls the brakes. If it's on, then it will physically stop the robot from moving, but if it's not selected, it will coast and the motor will be free to maneuver. For now, just leave it on brake for more accuracy. Finally, turn to your robot. This is where you can see the major differences between the two blocks come into play. You can either adjust this slider or you can set these speeds to different values. Personally, I have found that using the tank block, this one, rather than the steering block over here, is more accurate in the long run. But use whatever works for you. Now that we have this set in the program, we are you're officially telling the robot to drive forward while drifting to the left, because the left side has less power for 3 rotations. If we use our USB cable between the computer and the robot, we can see the robot's information come up over here. From here we can rename the brain, see information about the motors and sensors, and download the program onto the robot. The top button downloads the program directly onto the robot. The middle one runs the currently selected program on the brain, and the bottom one downloads and runs the program immediately. Right now we just want to download the program by clicking here or using the keyboard shortcut Control and D. You should hear this sound once it has been successfully downloaded, and you can run the program for yourself to make sure it works. If you want to run a single motor, you'll want to use one of these 2 blocks depending on the motor you're programming to use. The inputs that you're using are the same as the robot. Just make sure that the correct port is selected, otherwise it won't work. Something really important to understand about this program is that the blocks will not activate until the block before it is complete, and it always goes from left to right. This means that this motor will not move until the robot is finished driving. If we want the motor to move and the robot to drive at the same time, then there is a way to do that. Click on this part of the block right here and move the piece that you want to parallel nearby. Now you can pull this wire down until it locks into place, and it will run parallel to the other part of the program. Now we're going to want to look into different flows of the program. What you'll want to do is take this loop block and add it to the end. If you look on the drop-down menu right here, you can see all of the different options that you have. These are what will break the loop when they are true. For this example, I will be using the ultrasonic sensor I have attached to my robot and make the robot drive backwards until the sensor detects a value that is less than 3 inches. Again, make sure that it's in the correct port before you download it to the robot and test it for yourself. What is happening here is the code within this loop box will run forever until this is true or the program is stopped. The next session I want to discuss is the switch and wait blocks. The switch block essentially allows you to have access to the robot and make decisions about what course of action it can take within the program. Say I have a touch sensor attached to my robot in port 1. If the button is not pressed, I want it to turn left for 3 seconds, and if it is, I want my robot to turn right for 5. I can do this by adding a switch and selecting what I want. If I sense the robot is pressed, so I select this option, and I add in my drive blocks and set it to on. Now the always on selection is tricky. Like what we have over here, it can be a little bit difficult. They will always be on, so long as there is a reason to stop at the end or it's set for infinity. Otherwise, the program just ends. To fix this, we can use the wait block after this and set it to 5 seconds on the top when it's true and 3 seconds on the bottom. Of course, you can do this directly within the drive block, but the wait block has a bunch of different options that can help you do what you need. After this block, you can add whatever code you want for the next stage of the program. Finally, I want to discuss the option of messy code. Sometimes code can get really messy and difficult to follow. This is a problem that professional programmers face all of the time. To help avoid this, use comments to help keep track of points in the code so you or anybody else trying to help doesn't get lost. This can also help during the robot design portion of judging, where it's very highly recommended to bring a copy of your robot code to present. It's much easier to understand when it's commented. There's still a whole bunch of information to learn about programming, but this video is just to cover the very basics and get you started with the robot driving. I hope that this video has been helpful to you in learning about how to program your robot for competition. If you have any questions or if I missed anything that you think I should have included in this video, please leave them in the comments down below. It would be greatly appreciated. Also, if you'd like to support this channel and see more content about FIRST Robotics, please subscribe, leave a like, and ring the bell, because it really helps me see how I'm doing. Finally, I want to see who I'm reaching with these videos. So if you're with a team and have the ability, please leave the team name, number, and general location in the comments so I can see. Thank you so much for watching. Bye!